Generative AI has created some exciting innovations. And it's just getting started. Generative AI is also changing the data center landscape. Today, we'll look at how the data center industry is gearing up for a transformational shift. Let's start with a look at the front end of this tech tsunami, the relentless march of artificial intelligence, which has taken a giant leap forward this year. Thanks to the rise of generative AI apps like ChatGPT and Stable Diffusion, AI can now create stunning images, answer complex questions, write essays, develop websites, and even do programming, all with just a simple text query. Traditionally, AI systems were all about recognizing patterns in data, but generative AI takes things to a whole new level. It uses complex models to generate fresh content, whether it's images, text, or even audio, all based on natural language queries. AI is revolutionizing the way we live and work, but it's also bringing along new challenges for IT infrastructure. Take ChatGPT, for example. A Google search can power a 100-watt light bulb for 11 seconds, but a single ChatGPT session consumes 50 to 100 times more energy than that. In healthcare, AI-driven imaging applications are generating massive data sets, and that requires substantial amounts of processing power and storage capacity. In the world of academia, supercomputers like Sol over at Arizona State University are powering some pretty exciting research thanks to their massive computational resources. The financial impact of all this innovation is staggering. Bloomberg estimates that generative AI revenue will exceed $1 trillion by 2031, accounting for over 10% of the total tech spend. With this new technology, the requirements for data centers are going through a major transformation. AI is a power-hungry beast, demanding substantial computing, network, and storage infrastructure, often referred to as high-performance computing, or HPC. It relies heavily on graphics processing units, or GPUs, which are energy guzzlers, consuming 10 to 15 times more energy than traditional CPUs. Satisfying the appetite for this power requires huge upgrades in data center infrastructure to meet market demand. Capacity and power are the biggest issues facing the data center industry today. Enterprises, AI startups, and cloud service providers are racing to secure data center capacity for their AI workloads, with hyperscale clouds leading the pack. And this is happening fast. The TD Cowen Investment Bank and analyst firm reported a tsunami of AI demand, with 2.1 gigawatts of data center leases signed in the US, that's a fifth of the current supply, in the second quarter of 2023. By the way, 1 gigawatt is enough to power 876,000 homes for a year. Co-location providers like Iron Mountain Data Centers are scaling up their power for new builds in anticipation of AI requirements, and they're implementing critical structural changes to meet this demand. These data centers feature high-density power supplies to servers that can provide 30 to 50 kilowatts per rack, as opposed to the traditional average of 5 kilowatts per rack. Artificial intelligence is fueling rapid server innovation, especially in chip design. Take NVIDIA, a household name in the semiconductor industry. They invest billions of dollars in each new chip they develop. Their chips are in such high demand that they're even used as collateral. But with this accelerated refresh rate and increased capacity comes a significant challenge: the surge in electronic waste. E-waste is a fast-growing problem. By 2030, we're projected to produce a staggering 75 million metric tons of it annually. That's enough to make you wonder, what's lurking in all that discarded tech? Well, it turns out that global e-waste contains around $60 billion worth of precious materials, like gold, palladium, silver, and copper. But here's the kicker. only a mere 17% of global e-waste is properly recycled each year. The data center industry is rising to the challenge. As we witness these waves of innovation and e-waste, the climate crisis is deepening, and zero-emission targets are looming. The pressure on power grids is unprecedented, especially as industries move away from fossil fuels. And generative AI in particular is under environmental scrutiny. But there's hope. The power demands of generative AI are driving innovation in microgrids and backup power. Some of the biggest players in the tech world, including Iron Mountain data centers, have committed to using 100% renewable power. And what about all those old CPUs and GPUs left in the dust by the AI revolution? To keep our performance efficient and reduce our environmental impact, IT asset lifecycle management, as well as recycling, remarketing, and secure disposal are crucial. The industry is catching up, but we're about to witness an acceleration. At Iron Mountain, our Asset Lifecycle Management division is making a difference by sanitizing over 3 million drives each year and generating over $1 billion for clients through recycling and remarketing. Generative AI is changing not just the industries it serves, but also the infrastructure that supports it. If you're a data center customer venturing into generative AI, early planning and investment are key. You can learn more about AI and data centers at our website.